Hop on! I've prepared a tour around Earth's fellow planets. Let's start with Mercury, the smallest planet in the solar system. During the day, the temperature on the surface of this planet can reach 800 degrees Fahrenheit, and during the night, it can drop to negative 290 degrees Fahrenheit. The temperatures here are so extreme because the planet has no atmosphere. Instead of it, Mercury has a thin exosphere. That's one of the reasons why Mercury is not habitable. The temperatures and solar radiation are too extreme for any organism to survive there. Now let's imagine there's a way to live on Mercury. Then what would life there look like? Mercury's surface resembles that of the Moon. Over time, meteorites left lots of marks on it. Unlike the Moon's surface, Mercury is grayish-brown. Now look up. The Sun on Mercury would appear almost 3 times as large as it does on Earth. The sunlight would be almost 7 times brighter. I wonder what type of sunglasses people would wear if we lived there. Can life appear on this planet in the future? Don't get your hopes up, it's very unlikely. Now, how about landing on Venus? You might think the hottest planet in our solar system is Mercury since it's the closest to the Sun. But in reality, this title goes to Venus. What is it that makes Venus boil? The biggest reason is its atmosphere. It's made up almost entirely of carbon dioxide. The atmosphere is so thick that it leads to the planet warming up non-stop. Basically, the gases in the atmosphere prevent thermal radiation from leaving Venus. So, the planet simply can't cool down. The water on its surface constantly turns into vapor. If the surface of Venus was food, then its atmosphere would be the microwave. That's why the temperatures in this world can go up to 870 degrees Fahrenheit. What would it be like to live on Venus? On Earth, seasons change because of the planet's tilt, but Venus doesn't experience any significant changes throughout the year. Things are pretty constant at night and during the day too. And what about the view of the sky? The clouds on Venus appear yellow or bright white. They're mostly made of poisonous sulfuric acid, but then why does Venus appear reddish-orange when you look at it from Earth? Talking about the true colors of planets can be a tricky business. The hue of a space body might be different when you look at it from another planet. If we traveled all the way to Venus, a reddish-brown surface would welcome us. The molecules of carbon dioxide and sulfuric acid block sunlight coming into Venus's surface, hence the reddish-orange color of the planet. Oh, and did you know that Venus is often called Earth's twin? Both planets are nearly equal in size. Both have relatively young surfaces and thick atmospheres with clouds. Plus, the orbit of Venus is also the closest to Earth. That might raise a question about the possibility of life on Venus. I'm sorry to break the news, but nope. Venus is not habitable. The next destination is Mars. Unlike Venus, Mars has seasons due to the planet's tilt on its axis. It also has a secondary seasonal effect caused by its highly elliptical orbit. The southern hemisphere has colder winters and hotter summers than those in the northern hemisphere. The average temperature on Mars is negative 80 degrees Fahrenheit. But temperatures can also range from the poles to the equator, and they can change very dramatically within a single week. Still, not that bad compared to the previous 2 planets, huh? Is Mars habitable? The number one thing a living organism should worry about here is space radiation. Earth has a magnetic field and a thick atmosphere to protect its surface from radiation. Mars has neither. The planet's gravity is 1/3 of Earth's. So, weaker gravity and a thinner atmosphere make it harder for any living being to survive on the red planet. In 2013, NASA reported an ancient freshwater lake that could have been a hospitable environment for microbial life. This is evidence now that liquid water once flowed on Mars. This confirmation suggests that Mars could have had the necessary environment to support life. But what happened to the water on Mars? The most popular explanation is that the planet's atmosphere became too thin and cold to keep liquid water on Mars's surface. The disappearance of water might also be related to the loss of early magnetic fields. Or the reason might be the red planet's size. Mars is probably too small to keep water. So, for now, Mars is not habitable. But, scientists keep sending missions to Mars. Maybe they'll find some new information. Let's wait and see. Now, Jupiter. Have you ever wondered what it might be like to live on the biggest planet in our solar system? Jupiter's environment is an unlikely place to support life. The temperatures on this planet and its composition are too extreme for any organisms to appear there. Jupiter has layers of gas, mostly hydrogen and helium. These gases fill the entire planet. Quite literally, there is no solid surface on the planet. Gases go all the way to the core, below the surface. They become liquid and turn into plasma because the atmospheric pressure there is way more intense than any place on Earth. To put it into perspective, an organism on Jupiter has to resist 1,000 times more atmospheric pressure than it would on Earth. Can a living being survive in such conditions? Unlikely. Jupiter is completely uninhabitable. But hey, have you heard that its moon Europa might be a possible habitable zone? Change of scenery. Saturn. It's the second largest planet in our solar system. Like Jupiter, Saturn is a gas giant ball mainly consisting of hydrogen and helium. What about temperatures on Saturn? It's freezing. Plus, there are extremely powerful winds there. The winds in Saturn's upper atmosphere reach the speed of 1,600 feet per second. Let's compare them to storms on Earth to have a better understanding. The strongest hurricane ever recorded on Earth was moving at 350 feet per second. So the answer to the question, is there life on Saturn? Seems pretty obvious. Life, as we understand it, doesn't exist there. The next stop is Uranus, one of the largest ice giants. Uranus's atmosphere is dominated by ice, but it's not the only reason that causes the planet's blue color. It's also the methane in the atmosphere. It absorbs red light and reflects blue. The same goes for Neptune. Uranus is the coldest planet in the solar system. The temperatures there can be as low as -371 degrees Fahrenheit. Life on Earth needs sunlight to get energy, but there's nothing on Uranus that can produce any energy for life forms to thrive. The bottom line is Uranus doesn't have the environment to sustain life. Heading for Neptune, the second ice giant. What is there on the planet furthest from the sun? Obviously, it's incredibly chilly. There's neither a source of energy that bacterial life can exploit, nor a source of liquid water. Currently, scientists believe it's unlikely to find life on Neptune because of such unfriendly conditions. So, what makes our planet so livable? And I'm not just talking about human life, I mean any living organisms, even microbes. Life requires very special conditions to exist. All living beings need some sort of food, water, and the right temperature to develop. The atmosphere is a vital element. Humans, for instance, need oxygen to breathe, and they can only survive in temperatures that aren't extremely hot or cold. Another thing is gravity. All the other planets I've mentioned don't have exactly the same conditions as Earth. Life there would probably be different than what we have here. All living beings on Earth have adapted to our atmosphere, and life forms elsewhere would need to be able to survive in that planet's conditions.
There are many different conditions on other planets and moons that could affect how your pet would evolve there. Take gravity, for example. On a bigger or denser planet, gravity would be higher, meaning that life would evolve to be shorter, sturdier, and perhaps with multiple limbs for structural support. On a lighter planet with weaker gravity, life could hop, soar, and glide more easily, and would be more likely to evolve a lighter, taller build. Mars is the fourth planet from the Sun, a dusty, cold, desert world. Mars is also a dynamic planet with seasons, polar ice caps, canyons, extinct volcanoes, and evidence that it was even more active in the past. Gravity on Mars is lower than on Earth, and it's farther from the Sun, so we would see less sunlight. Mars also has no protective magnetic field due to its thin atmosphere, exposing everything to radiation. Sometimes, strong winds create dust storms that howl around the whole planet, and the dust continues to settle for months after. Your pet dog on Mars would probably have a taller, robust build to compensate for poor gravity, and would have bigger eyes to better perceive the far-off sun. To protect itself from radiation, your dog would have to switch its pigmentation from melanin to carotenoids, which give carrots, tomatoes, and oranges their color. So the dog would probably have orange skin. Since Mars has weak gravity, your cat would probably be lighter and would jump more to get around the place. It would also have longer legs. Jupiter is called a gas giant, The planet is covered in thick red, brown, yellow, and white clouds. The clouds make the planet look like it has stripes. Living on the surface of Jupiter might prove to be challenging, since there's no actual surface. The planet consists entirely of gas, but it doesn't mean it's just a giant cloud hanging in space. If you venture through its atmosphere to deeper parts, the gas becomes denser until it turns into liquid. So one layer of Jupiter is an ocean made of hydrogen instead of water. With high pressure, extreme temperatures, and a fluid environment, we'll have to draw some inspiration from deep water dwellers who deal with the same conditions but on a smaller scale. Your cats and dogs would be big isopods with shells to protect them from Jupiter's radiation. Like its fellow gaseous neighbor Jupiter, Saturn is a gargantuan cloud of hydrogen and helium with no solid land and powerful winds. Like Jupiter, it gets tighter within, but its core is much smaller. Its iconic rings are made of a myriad of ice particles, so nothing could live on them, unfortunately. Saturn's volume is greater than 760 Earths, and it's the second most massive planet in the solar system, about 95 times Earth's mass. Saturn's average density is less than water, so this behemoth of a planet could float in a bathtub if there were one of a suitable size. The only way to move within Saturn's thick fog is by flopping around like a jellyfish. Your dog would probably have an umbrella-shaped bell to propel itself up, and no skeleton, so that it wouldn't be crushed by the pressure. Your cat would have jellyfish tentacles to move around. Life is tough on Mercury. This tiny planet is closest to the sun, so the sunlight here is 7 times more powerful than on Earth. No sunscreen would be able to manage that. Mercury is about 2/5 the size of Earth, with a similar gravity to Mars, or about 38% of Earth's gravity. This means that you could jump 3 times as high on Mercury, and heavy objects would be easier to pick up. Mercury's temperature is extreme, swinging between a scorching 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. It's all accompanied by constant meteor showers and quakes. As a bonus, there is a very thin atmosphere and no air to breathe. Flesh and bone could never handle these severe conditions, so instead, your pets here would be made of something similar to refractory metal, like titanium. There'd be no need for a respiratory system, so their pretty metal faces would be without a nose, and their eyes would probably look like thick sunglasses to protect them from all this sun exposure. If there's anywhere harder to live than on Mercury, it's Venus. Venus is the second planet from the Sun, and is Earth's closest neighbor in the solar system. Venus is the brightest object in the sky after the Sun and the Moon, and sometimes looks like a bright star in the morning or evening sky. The temperature here is a whopping 880 degrees Fahrenheit, and the atmosphere is so thick, it creates a greenhouse effect. The surface is dry and full of surprises like volcanic eruptions, hurricane winds, and lightning. And, as a cherry on top, the pressure here feels like you're 1 mile underwater, giving you a never-ending headache. It would be hard to imagine your pet living on Venus. The only things that could possibly survive there are anaerobic bacteria. Venus eats away at everything, even metal, making quick work of any human spacecraft. And Venus's atmosphere contains phosphine, which is toxic for anything that breathes oxygen, but means life for microbes. Icy, dark, and plagued by strong winds, Uranus and Neptune are mostly made of cold liquids, methane, water, and ammonia. Methane makes Uranus blue, and it has faint rings, while Neptune is dark, cold, and very windy, as it's the last of the planets in our solar system. It's more than 30 times as far from the Sun as Earth is. Neither of them has a solid surface, and their atmospheres slowly merge into the water around the planet's core. To boot, gravity on Neptune is stronger than on Earth, and applies more pressure on everything. With such powerful gravity, your dog would be shorter, and your cat would be stockier, with muscular bodies and thicker skins against the cold. And considering the fluid environment, your pet's best bet is to become like a cosmic whale or manatee, floating around the blue planets. Pluto is not very big. It's only half as wide as the United States. Pluto is smaller than Earth's moon. This dwarf planet takes 248 Earth years to go around the Sun. If you lived on Pluto, you would have to wait 248 Earth years to celebrate your first birthday. 1 day on Pluto is about 6.5 days on Earth. the farthest planet-like object from the Sun is appropriately freezing cold and covered with ice, with weak gravity and a flimsy atmosphere. The Sun, from Pluto, is nothing more than a dot on the horizon, much like the Moon for Earth, so there's not much going on in terms of light. But scientists suggest that there may be a water ocean under Pluto's surface and some nicer weather. Let's take notes from Earth's creatures with built-in antifreeze, like some insects and fish. Low gravity makes the muscles and bones shrink, and the space between vertebrae expand, making your pets taller. Their posture would also change, since their spine, for the most part, would be out of a job. So they'd probably be tall, thin, and somewhat spider-like, with spindly limbs and a curved spine. On other planets beyond the solar system, the boundaries between plants and your pets could be blurred, and your pets might merge with plant life. Your pets might become tree-like, with beating hearts attached to their bodies, or with feet to move to better positions as they compete for light and water. You could also have a rabbit that spends most of its time staying still, photosynthesizing, and only running away if threatened. Or a massive dinosaur-like horse that splays itself out on the ground to get nutrients directly from the soil and obtains extra energy with the help of plants on its back. Cooperation could lead to some fascinating pets, such as a sea of amoeba acting as a single jelly-like mega creature, thousands of voracious shrimp-like carnivores forming a single organism that devours anything in its way, or a web of intertwined trees that collect water in wide pitchers at the top of their canopies. Getting oxygen to muscles is a key for your pet's endurance. Here on Earth, octopuses use a copper-based molecule in their blood to shuttle oxygen, making them more sluggish than mammals and birds that use iron-based hemoglobin. Scientists have speculated about other types of oxygen transport that could make animals fitter. In atmospheres with more oxygen, we might see a pet monkey that can fly without ever having to stop for a rest. On cold planets and moons without much sunlight, such as the moons of Saturn and Jupiter, your pet dog might have to get by with chemical energy rather than take it from the sun. Also, in worlds without light, such as the depths of Enceladus's oceans, there might be little need to evolve eyes. Pets would probably sense their environments using other means, like gills and vibration sensors.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing towards the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the Moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the Moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile-thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, we'll have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So, maybe we take that effort and save us from a real threat, climate change. Just saying.